In my last lecture, I discussed null hypothesis, alternative hypothesis, and its formulation in different situations. Today, I propose to discuss the two types of error that we are likely to commit while testing a hypothesis. A hypothesis is always regarding some population. And in statistics, population is a technical term, the concept of which is a bit different from what we commonly mean. In statistics, by population, we do not mean only human population or population of some living beings only. Population in statistics is defined as a set of similar items or events which is of interest for some question or experiment. It is the aggregate or totality of items under study. Obviously, to test a hypothesis which is regarding a whole population, the whole population cannot be enumerated, as populations are generally very large, sometimes even infinitely large. It's practically not possible to consider each and every member of the population. So what we do in such cases? We take random samples from such populations regarding which hypotheses are to be tested. A hypothesis is tested on the basis of this random sample drawn from the population. That is, on the basis of a part of the population, on the basis of a fraction of the population, not on the basis of the whole population. So, we are always likely to commit error in our decisions. We cannot be any time sure that the decision to reject or to accept the hypothesis is correct with probability 1. In other words, we cannot claim that our decision of either rejection or acceptance of a given hypothesis is always true. Howsoever modern and sophisticated technique of hypothesis testing could have been applied. We can be sure about the correctness of our decision only in one case, when all the population units are enumerated. That is, the whole population is studied, which is practically not possible. So, whenever we test a hypothesis, there is always a chance that our decision is not correct. It may have some error. Let me give you one example. Suppose that you are told that in a closed room 20 persons are sitting, and you are standing somewhere near the door of the room. You are not seeing inside the room. After some time, the door opens and a person comes out. You observe that he is a man. Then another person comes out. You observe that he is also a man. Then third, fourth, fifth, 16th, 17th, 18th, 19th person come out, one after another. And you observe that all are men. One person is left in the room. Can anybody of us say with certainty that the person left in the room is also a man? Certainly not. If somebody is saying that he is also a man, it is just his guessing. He can't be sure that the one person left in the room is also a man. So, if observing 19 out of 20, you cannot be certain, how can you be certain about correctness of your decision taken on the basis of a few observations out of very large populations? Just observing 30, 40, 50, 60 observations out of large populations, out of infinitely large populations. So, error is inevitable. Sometimes we may reject a hypothesis when it should not be rejected. And sometimes we may not reject a hypothesis when it should be rejected. So there will be always chance that there is error in our decision. We can't claim with 100% surety that whatever decision we have taken regarding the hypothesis is correct. This claim we can make in only one situation. When you consider the whole population, when you enumerate each and every unit of the population, then only we can say with certainty that our decision is correct. So far we are going to test a statement, a hypothesis regarding the whole population on the basis of a few observations. There is always likelihood that our decision may have some error. These errors are of two types. Let us try to understand in this way. A hypothesis has only two possibilities. It may be true, it may be false. Our decision is to take either of the two, either to reject the hypothesis or to accept the hypothesis. So there are two possibilities on a hypothesis, true or false. Our decision is twofold. We may reject, we may accept. So in this way, 2 into 2, that is equal to 4. there would be total 4 possible situations. Now let us consider each of these 4 possible situations. One situation would be that the hypothesis is true and you have taken a decision to reject it. The second possibility would be that the hypothesis is false and you have taken a decision to accept it. The third possibility would be that the hypothesis is true and you have taken a decision to accept it. And the fourth possibility would be that the hypothesis is false and you have taken a decision to reject it. So there would be altogether these 4 possible situations. Out of these 4 situations, in 2 situations, we are committing error. What are those situations? Null hypothesis is true and we are rejecting it. It is a wrong decision. We have committed an error. The hypothesis is false and we have taken a decision to accept it. It is also a wrong decision. A false hypothesis should not be accepted, it should always be rejected. But we have taken a wrong decision. So we have committed an error. So at these 2 places, at these 2 situations, we are committing error. And in the rest 2 situations, we are not committing errors. Our decision would be correct. If the hypothesis is false and we are rejecting it, it is a correct decision. If the hypothesis is true and we are accepting it, it is a correct decision. So out of 4 situations, out of 4 possible cases, in 2 cases we are committing error, and in the rest 2 cases we are not committing any errors. So these 2 cases where we commit error, we give name as type 1 error and type 2 error. When we are rejecting a hypothesis when it is true, this is called type 1 error. So rejection of a true hypothesis is type 1 error. And when we are accepting a hypothesis when it is false, then it is known as type 2 error. Acceptance of a false hypothesis is type 2 error. So type 1 error and type 2 error. Very simple. If the hypothesis is true, and you are rejecting it, you are committing type 1 error. If the hypothesis is false and you are accepting it, you are committing type 2 error. In economic terms, type 1 error is known as producer's risk, and type 2 error is known as consumer's risk. Now the question is, how should we develop our test? we test our hypothesis. Everyone would agree that our test should be such that the probabilities of these two types of errors are minimum. There is no controversy in it. We can't make these two types of errors, we can't bring these two types of error at zero level. We can't make probabilities of these two types of errors zero. Alas, that would have been the situation. But so far we are testing a hypothesis on the basis of a fraction of the population. There is always possibility, there is always probability, some positive probability, non-zero probability that error is committed. Generally, the probability of type 1 errors, that is the probability of rejection of a true hypothesis, is denoted by alpha. And the probability of type 2 errors, that is the probability of accepting a false hypothesis, is denoted by beta. So, undoubtedly, that test would be the best test, where alpha and beta probabilities of type 1 error and type 2 error are at minimum level. But the difficulty is this, that we can't minimize alpha and beta both simultaneously. Error is error, whether that is type 1 error or type 2 error. We should have a test where probability of type 1 error is minimum and the probability of type 2 error is also minimum. But the difficulty is that we can't minimize both the probabilities of both types of errors simultaneously. If we try to minimize one probability of one type of error, the probability of the other type of error automatically increases. If we try to minimize the probability of type 1 error, that is probability of rejecting a true hypothesis, probability of type 2 errors, that is probability of accepting a false hypothesis, increases, and vice versa. So how to manage this situation? This is true that test is good test. That test will be the best test when these two probabilities are at minimum level. There is no doubt in it. But at the same time, it is also true that we can't minimize the probabilities of both types of errors simultaneously. We can't make alpha and beta minimum simultaneously. If we try to minimize alpha, beta increases. If we try to minimize beta, alpha increases. This is also true. This is the difficulty. So how to manage this situation? Now this we would discuss in our next meeting. Wait for that. Thank you very much.